Triado. Uh, we are studying Introduction to Organic Chemistry. Last time we saw how functional groups are related to their homologous series, and today we'll be studying hydrocarbons and some naming conventions of organic chemistry. So let's start with hydrocarbons. So, as the name suggests, hydrocarbons are compounds that have carbon and hydrogen atoms only. So compounds having carbon and hydrogen atom only. Compounds. So uh, com- uh, no other element can be part of hydrocarbons, right? All right. Having said that, there are different types of hydrocarbons that we'll be studying. So let's classify the three types of hydrocarbons. So the first type of hydrocarbons are aliphatic hydrocarbons. Aliphatic. Aliphatic hydrocarbons. Aliphatic simply means straight chain hydrocarbons. So hydrocarbons that are in the form of straight chains, right? Uh, Aliphatic hydrocarbons further are of two types. The first one are saturated aliphatic hydrocarbons, and the second ones are unsaturated. In my previous videos, I've explained what is the meaning of saturated and what is the meaning of unsaturated. Saturated simply means that it contains carbon-carbon single bonds only. So contains carbon-carbon single bonds only. Single bonds only. And ali and unsaturated means that it either contains a double bond or a triple bond, but for the purpose of this syllabus we'll restrict the definition to contains a carbon carbon double bond, at least one carbon carbon double bond, right? As simple as that. uh, for saturated aliphatic hydrocarbons we have alkanes, and for unsaturated we have alkenes and alkynes. Alkenes and alkynes, right? Now coming to alicyclic hydrocarbon. The second type is alicyclic hydrocarbons. Alicyclic mean rings, right? So these are hydrocarbons that are in form of rings, and the examples would be cycloalkanes and cycloalkenes. Now some of you might ask this question of whether there can be cycloalkynes. So just as a tidbit, remember that a ring can either have a double bond, can either have a triple bond or a ring. So a compound can either have a triple bond or can be in the form of ring. A ring structure cannot have a triple bond in it. So ring structures don't have triple bond in it. Rings don't have triple bond, right? I hope this is clear. And the last one are aromatic hydrocarbons. Aromatic hydrocarbons. Aromatic hydrocarbons, they are broad classification, but just as an example, let's say benzene. Benzene is an example of aromatic hydrocarbons, but we'll be learning the details of them in A2 syllabus. I hope this is clear. Now, if this is clear, We can now move on to the naming conventions that are used in organic chemistry, right? So let's see the naming conventions, or as it is known as the nomenclature. So as far as the nomenclature is concerned, so for example, if we have one carbon in the compound, it's known as meth, two carbons eth, three carbons prop, four carbons but, five carbons pent, six carbons hex, seven carbons hept, eight carbons oct, nine carbons non. You need to know till nine carbons only, right? So let's give an example. So this compound containing two carbons and has an alkene in it, so it will be eth because it has two carbons, and ene for alkene. Okay. Another compound with with an alkyne functional group, this would be known as eth and yne, ethine, right? And this compound with three carbons and an OH group. Let me draw the hydrogens here. Same for here. So a compound with three carbons and an alcohol group, this would be known as propanol. Propanol, right? I hope this is clear. Of course, along the way, we'll be doing other examples as well, and naming will then be easier for you, uh, of course. Having said that, I just want to clear a few things up before we move on to the next video and to isomerism. Let's be clear on a few things. In whole of organic chemistry, how is a bond broken, right? So let's see, how does a bond break in a reactant. The question is, how does a bond break in a reactant? Right? Now, in whole of organic, covalent bonds will be broken through two techniques, right? The first one is homolytic fission, and the second one is heterolytic fission. So the first one is homolytic fission, and the second one is heterolytic fission. Now let's understand what homolytic and heterolytic mean. As the name homo might suggest, it means equal sharing of bonding electrons. So when a bond breaks, so for example, we have this bond between two chlorine atoms. When this bond breaks, the bond contains two electrons, right? The bonds are equally distributed. So one electron goes to one chlorine and the other electron goes to the other chlorine when the bond is broken. So this is known as homolytic fission, and it is represented by a half curly arrow. The half curly arrow shows the movement of one electron. Movement of one electron. Right? Now, as a definition, homolytic fission is done when there is equal distribution of bonding electrons. When the bond breaks, of course. The second one is heterolytic fission. So for example, we have HCl. Now, HCl is a polar bond with chlorine having the partial negative charge and hydrogen having the partial positive charge. Now, having a partial negative charge means the electrons are more attracted towards the chlorine nucleus. They are present at the chlorine atom more frequently than at the hydrogen atom. That means when the bond will break, this might happen that both the electrons go towards the chlorine and no electron goes towards H atom. That means that the full curly arrow shows movement of two electrons, right? And this would occur when there's unequal distribution of bonding electrons. As simple as that. Now, here's the thing. When there's equal distribution of bonding electrons, the resultant will be two chlorine atoms or two chlorine radicals. So, chlorine radicals. What are radicals? Radicals are species with free electrons or unpaired electrons. Species with unpaired electrons. They don't have any charge per se, but they have an unpaired electron, and having an unpaired electron makes them very susceptible to reactions because they need to fulfill their electrons, so they're highly reactive. On the other hand, when such a case occurs, a positive ion is formed and a negative ion is formed. The negative ion, or the electron rich species, so this is electron rich species, is known as the nucleophile, and the electron deficient species is known as the electrophile. So electron rich species is known as the nucleophile and electron deficient species is known as an electrophile. That means homolytic fission leads to radicals and heterolytic fission leads to nucleophile and electrophile formation. Right? I hope this is clear. So, as far as the introduction to organic chemistry is concerned, we're done with hydrocarbons, we're done with the naming convention, and we're done with the bond breaking. Now, the next thing that we'll be doing is isomerism and the types of formulae, but that will be done in the next video. I hope everything from this video is clear, and I hope you're enjoying the series. Thank you so much.